Okay, good afternoon, evening, morning, wherever you're at. We are doing section 8.1, find angle measures in polygons. So 2 learning targets today. One is finding angle measures in polygons using interior and exterior angles. And the other one is the other learning target is finding angle measures in a regular polygon. Vocab word, diagonal. We've talked about this briefly before. So the diagonal connects to non-consecutive vertices. So there's one diagonal, another diagonal from that same vertice would be that one. Those are the only 2 diagonals from that vertice, from that vertex that I can draw. Okay. We have theorem 8.1, the polygon interior angles theorem. What this is saying is if I add up all the angles in my polygon, it will give me the number of sides, which is n. So n is the number of sides, minus 2. So the number of sides minus 2 times 180. So if I add up all the measures, I will get the number of sides minus 2 times 180. Corollary to that theorem is the interior angles of a quadrilateral, and that just says the sum of the measures of the interior angles of a quadrilateral is 360 degrees. And we already know the sum of the angles of a triangle, which is also a polygon. That's 180. So 2 theorems. Key here is whenever you see this n, we're talking about number of sides. So n is going to stand for a number of sides. That's why we have an n-gon. N-gon is an n-sided polygon. Polygon exterior angle theorem. The sum of the measures of the exterior angles of a convex polygon. Exterior, one angle at each vertex is 360. So if I take one of the exterior angles of each vertex and add them together, my answer will be 360 degrees. Remember that from each angle I can get more than one exterior angle. So I'm only taking one angle from each vertex. So now we just have to apply it, and it's Pi Day today, so I'm going to give you a Pi Day joke. How many calories are there in a slice of chocolate pie? Oh, approximately 3.14. Ha, ha, ha. Okay, let's do number 1 here. Find the sum of the measures of the interior angles of the convex decagon. So a couple of keywords here. Convex, do you remember what convex mean? There were 2 different types of polygons, convex and concave. Convex means that it wasn't going in. Concave meant that there was a dip inside the polygon. Basically, that's how you guys define it. The definition, though, in convex is that if I extend any one of the sides, it will never go into the polygon. So first thing I need to do is know that a decagon means 10. So this is a 10-sided figure. So if I want to find the sum means add it all together. So the sum of the measures of the interior angles, I just need to use the formula from theorem 8.1, which was n minus 2 times 180. So that means I'm going to do 10 minus 2 times 180, which is 8 times 180, which is 1,440 degrees. So the next one says the sum of the measures of the interior angles of a convex polygon is 1,620 classify the polygon by the number of sides using the same formula. Why? Because it says the sum of the measures is equal to this. And again, it's a convex polygon. So if you extend all the lines, never going to go into the interior. So we do n minus 2 times 180 is equal to 1,620. So this time I'm dividing. 1620 divided by 180 is 9. So I have n minus 2 is equal to 9. I'm adding 2 to both sides to get n is equal to 11. So this figure should be an 11 gon. Okay, 2 more examples quickly. A convex pentagon. So pentagon means 5. Has exterior angles with measures 66, 77, 82, and 62. What is the measure of an exterior angle at the 5th vertex? So pentagon means 5, so there's 5 sides. There will also be 5 angles. And so when I'm looking at this, I need 5 angle measures. I only have 4. Now we're talking about an exterior angle here. So we were talking about theorem 8.2, which said the sum of one exterior angle at each vertex is going to be 360. So I do 360 is equal to 66 plus 77 plus 82 plus 62 plus x. And I would solve for x. So when I solve this, I get x is equal to 73 degrees. The exterior angle of the 5th vertex would be 73 degrees. The last one, find the measure of each interior angle and each exterior angle of a regular nonagon. Nonagon is 9 sides. Regular means all angles are the same. We'll start with A. We want each interior angle, so we're going to use the 9.1 theorem, n minus 2 times 180. So here 9 minus 2 times 180, which would be 7 times 180, which is equal to 1,260. Since each angle is going to be the same because it's a regular nonagon, then I'm going to do 1,260 divided by 9. Why? Because there are 9 angles inside that polygon. That is going to be 140 degrees. So my answer to A is each angle is 140 degrees. Okay, so when I'm looking at B, instead of doing this work, we know one angle at each vertex, exterior angle, is going to add up to 360. So I have 360 divided by 9, which is 40 degrees. So each exterior, this is interior, each exterior angle is 40 degrees. Done.